Hello guys, welcome to our first video. Today we are going to show you how to make an Arduino oscilloscope. But first, let's start with some basics. Here you can see the digital pins of the Arduino Mega. And there are the digital pins of the Arduino UNO. Here are the analog pins of the Arduino Mega and here of the UNO.
Before we start programming the real oscilloscope, we are trying out the analog read function, with which we can later on measure our waveforms. First off, we are going to start setting a variable, which we are going to call a readout. Then we are going to write the pin mode function, with which we declare if a pin is an input or an output. We are going to use pin A15. Then we are going to begin the serial communication with a baud rate of 9600. Now we are going to declare the variable readout. So we are going to basically say the program that it should read out pin A15 and save the value in the variable readout. Now we are going to print this out with the serial.println function. And we're going to set a little delay of 100 microseconds.
Here we power the pin A15 of the Arduino Mega with the lab bench power supply. And you can see on the multimeter the voltage we're putting in, and on the left side you can see the values the Arduino spits out.
By changing the code a little bit, we can let the Arduino spit out the real voltage instead of just some weird numbers. First, we have to change the variable to double, because this variable type can save point numbers. Then we're going to divide the readout by 1023 and multiply it by 5, because the range of numbers we got earlier was from 0 to 123, and by dividing this by 1023 and multiplying it by 5, we get the accurate voltage.
Now we are powering the pin again, and the Arduino spits out voltage values.
At the beginning, we are setting some basic settings for our display. Without them, the TFT display wouldn't work. For example, here we define some colors, otherwise we would always have to write these hexadecimal values instead of just these names of the colors. Here we are defining some variables. The most important one is an array, which saves our measured data from the input A15. In void setup, we define the pin modes. A15 is the input for our signal which we want to measure. A14 is the input for the potentiometer, and these three are inputs for the buttons. In void loop, it starts with the readout of the potentiometer, and the readout gets saved in this variable called poti. Then if the button left is pushed, then we count plus 20 to the variable go, and if the other button, if button right is pushed, we subtract 20. If the hold button is pushed, it either clears the hold message or shows the hold message. And if the hold message is shown, the whole thing stops and you can analyze your waveform. Here it prints the microseconds per dot. This is basically the readout of the potentiometer, because here we have a loop that reads out pin A15, and here it waits the value the pot is set to, and the red data get saved in the array save. And this all just happens if hold mode is false, so if the button is not pushed. Here is another loop in which the values are printed, and here we also count go to this number. The loop runs through, and every time it runs through it counts plus 1, so it starts with 0 and counts up to 320. And here we add go, so the value we set, we want to go further or back, and then it reads exactly this position out from the saved array, and then it prints it here. And if the Arduino is in hold mode, then it waits till either one of these buttons is pushed. So if either the right or the left or the hold button is pushed, then it delays 500 microseconds, and then it fills the screen black and all starts again. But now let's look at the results. Here you can see a little timer 555 circuit that spits out a rectangular waveform and feeds it into the Arduino. On top you can see my pocket DSO, and the waveforms look pretty identical. Here is just a little note. This is an older version of it where we didn't have the buttons for hold, left and right. I will show you that in a minute. By turning the potentiometer of the Arduino, you can see how the time base changes and how the waveforms get bigger and smaller. By adjusting the potentiometer of the timer 555 circuit, we can change its frequency. And also here you can see how this changes on the Arduino display.
You can see we made ourselves a little shield for the buttons and for the potentiometer. By pushing the frequency button, the Arduino shows the on and off time of this square wave. By pushing it again, it shows the frequency. The Arduino measures 99 Hz and the pocket DSO measures about 99 Hz too. By pushing the hold button, it pauses the measurements. By pushing the left button, the measurement moves to the left. By pushing the right button, the measurement moves to the right. We hope you enjoyed watching us. Please like, share and subscribe, that would help us a lot. If you know what we could do next time, please write it in the comments.